Hello, and today's video is a short recording on a short review on everything from chapter 6 that we've learned so far. So let's start off this, since our unit is mostly about finding area and perimeter of polygons, let's start off with a couple of things that we already know about polygons. First of all, if we want to find the interior angles of a polygon, when we're talking about the interior angles of a polygon, let's just use a pentagon for an example. The interior would be the number of degrees on the inside of a polygon. So if I added those all up, that would be the sum of the interior angles of that polygon. And the way that we find that is that n minus 2 times 180. And we actually originally discovered that by just drawing a bunch of triangles into that polygon, and if each triangle has 180 degrees in it, that's where we came up with this formula here. So if I wanted to find the interior angles of a convex pentagon, a pentagon has 5 sides. The number of sides is 5. 5 minus 2 times 180 is 540. If it was a hexagon, our n would be 6. 6 minus 2 times 180. 6 minus 2 is 3. 3 times 180 is, 6 minus 2 is 4. 4 times 180 is 720. Exterior polygons, when we look at the exterior of a polygon, we're going around the outside. Exterior means outside, and it is always 360 degrees no matter how many sides that polygon has. So if I look at the exterior angles of this example here, I would just add all of these things up and set them equal to 360. So if I do 70 plus 60 plus 65 plus 40 plus y equals 360, I can combine my like terms. When I combine my like terms, 60 plus 70 plus 65 plus 40 plus y, we get 235 plus y equals 360, and we could subtract the 235 from both sides, and our y equals 125. Same idea would go for this example as well, except for in this case we have 2 y's, so we would again add all the things up, but I like to put all of my numbers all together, and then I would put my y's together. So if I do 59 plus 50 plus 35 plus 61, it'll make combining my like terms a little bit easier. Again, I'm adding them all and setting them equal to 360 degrees. If we combine our like terms, we have 3y. When we combine all of our degrees, we get 205 degrees. And we're going to get our y's by themselves. When we subtract 360 minus 205, we get 155. Divide both sides by 3. Y equals 51.6. The central angle of a polygon is when we're taking a look at some sort of a polygon. Let's say this time I'll draw a hexagon. If the central angle is in the middle, so the difference between the interior angles and the central angle is just what is just one of these measures if we break this up into a bunch of triangles. So the central angle, the formula of that is 360 degrees divided by n. So in this case, if we had an octagon, our n would equal 8, so we'd do 360 divided by 8. 360 divided by 8 is 45 degrees. Finding the area and perimeter of a polygon. So first of all, if I wanted to find, in this case right here, we have an octagon. First of all, the area formula is the apothem times the number of sides times the side length divided by 2. The perimeter formula is simply just whatever the side length is times the number of sides. We could also use that perimeter formula in our area as well, because since S and N are both in our area formula, we could just take the apothem times the perimeter divided by 2. If taking a look at our octagon here, our apothem is 12.1. Our number of sides, since it's the octagon, is 8, and our side length is 10. So if I plug these all in, I'd have 12.1 times 8 times 10 divided by 2. If I multiply those all together and divide by 2, I get 484. Now if I was to do the perimeter would simply be the number of sides, which is 8, times the side length, which is 10, which would be 80. If for some reason we're not given the apothem, the number of sides, and the side length, we have to get a little creative. So in this case, we have a pentagon. We don't know our apothem. We know our number of sides. It happens to be 5. We were able to count this. And we don't know our side length. So the first thing that I want to think about is, how can I break this this shape up into some triangles? And what I first want to think about is, what is my central angle? So if my central angle is 360 divided by the number of sides, 360 divided by 5 is 72. What this is going to help me find, 72 degrees. If that is each of these triangles, this vertex is 72 degrees, then if I split this in half into 2 right triangles, half of 72 would be 36. What I'm trying to do here is I'm trying to create a right triangle, because if we're able to create a right triangle, we're able to find missing measures of that right triangle. So the end goal here is to have some sort of right triangle, because if you have a right triangle, you have a hypotenuse, you have an angle, let's call it theta, and we have an adjacent and an opposite. Now this adjacent is also the apothem, and this opposite is 1/2 of the side length. So if I can figure out what my apothem and my adjacent is, or my opposite side and my adjacent side, I should be in good terms as far as plugging into our A times N times S divided by 2. So there's a couple of different strategies that we could use for that. Depending on what we have, we could, ideally it would be nice if we could use the Pythagorean theorem. If we can't use the Pythagorean theorem, special right triangles. Or SOHCAHTOA. In order to use the Pythagorean theorem, we would have had to have had 2 parts, so maybe like the apothem and the apothem and the radius, or maybe the side length and the radius to solve for the apothem. So we have to have 2 of the 3 sides. In order to use special right triangles, this would have to be a 30, 60, 90 degree triangle. Unfortunately, in this case, it is not a 30, 60, 90 degree triangle or a 45, 45, 90 degree triangle. We have 36 degrees. 36 degrees is not any special type of triangle, so we have 36 degrees. The hypotenuse is 4, and we're going to try to find both the apothem, which would be our adjacent, and our opposite, which would be half of our side length. So in this case, we have to use SOHCAHTOA. for this example, I'm going to find the adjacent first, which is our A. So I'm going to call that A. This 4 is my hypotenuse. So when I set this up, I'm going to do cosine of 36 degrees equals, because cosine is adjacent over hypotenuse. So I'm going to go A over my hypotenuse, which is 4. Now the first step is just plugging it in. Now we're going to do our decimal step. We're going to turn cosine of 36 into its decimal form. So if you use your calculator in degree mode, we're going to do cosine of 36. Cosine of 36 is I'm going to go 4 decimal places. 0.8090 equals our A over 4. Now this fraction is just over 1, so if I want to cross multiply in order to use the cross product property, and A times 1 is just going to be A. 4 times 0.8090 is going to get us about 3.24. So our apothem is 3.24. Now that I have 2 of the 3 sides, I could do SOHCAHTOA one more time to find my opposite. In that case, I would use sine. But since I have 2 of the 3 sides, I can use my Pythagorean theorem. So let's do the Pythagorean theorem in order to find our last side. Let's call it x in this case. So if I have my apothem, which is 3.24 squared, plus my opposite squared should equal my hypotenuse, which is 4 squared. When we square each of those, 3.24 squared is 10.49. We don't know what x is, so we'll leave it as x squared. 4 squared is 16. Subtract 10.49 from both sides. We get 5.5. And when we take the square root of those, we'll get about 2.3. So if my x here is 2.3, that means that what we just found here is half of the side length. So if this half is 2.3, this half is also 2.3. Again, you could just multiply that by 2. If we put them together, we get 4.6. Our apothem, we found that earlier. That was the first thing we found using SOHCAHTOA. So that was the 3.24. So we have our apothem, we have our side length, and we have our number of sides now. So we are able to plug these all into our formula. So our apothem times our side length, or times our number of sides, which is 5, we just counted, and our side length, which is 4.6, divided by 2. Multiply those all together, divide it by 2, and we should get about 37.26. Lastly, just a couple of circle examples. Area of a circle is pi r squared, so if we have a diameter of 10, that means our radius is going to be 5. So if we plug in our 5 for our r, we're going to have pi times our r squared. 5 squared is 25, so we can just leave it as 25 pi. Now if you want to get a decimal answer, that's fine. terms of pi is fine. Circumference formula is 2 pi r, so we're going to do 2 times pi times our radius, which is 5. We could just leave it as 10 pi if you'd like. Finding sector area and arc length. Sector area is always whatever the measure of our angle over 360 times the area formula, which is pi r squared. So pi times our r in this case is 10 squared. Multiply those all together, we get 34.8 repeating. If you wanted to leave it in terms of pi, that would be completely fine. Arc length is our measure of our angle over 360 times 2 pi r. In this case, it's 10. If we multiply those all together, 40 divided by 360 times 2 times pi times 10, we get about 6.97, and the 7 is repeating. So hopefully this is a helpful guide to reviewing some of the things that we looked at with area and perimeter of polygons, and a couple of other properties of polygons. So thank you for watching.